Hey guys, it's Oriana. So today we're going to do a problem with the flight computer and magnetic heading.
I am free, yeah, yeah, come water me. Oh.
Alright, so this next problem, 9-7, we're looking for the magnetic heading. So refer to figure 21, determine the magnetic heading for a flight from Mercer County Regional Airport to Manoy International. The wind is from 330 degrees at 25 knots, the true airspeed is 100 knots, and the magnetic variation is 10 degrees east. Alright, so again, the first thing you want to find is your true course. So you're going to draw a line between your first airport, Mercer County Regional, and Manoy International up here, which we've already done. And then you are going to find the true course by using your plotter. Use the right way or the wrong way, whatever strikes your fancy. And we can see here that the course is about 12 degrees. So we're going to write that down. Our true course equals 12 degrees. Now this is the first problem that you're going to have to bring your flight computer into play. So we talked about true course, which is the course that you plot on your map, magnetic course, which is the true course plus or minus your magnetic variation, but now we want magnetic heading, which factors in the winds. So we have our given information. So wind is from 330 degrees at 25 knots. Our true airspeed is 100 knots. Our magnetic variation is 10 degrees east, and the true course that we just found was 12 degrees. So you're going to bring out your plotter, and first thing you're going to do is line up this little arrow above TAS. TAS is just your true airspeed with the number on this white outer ring that corresponds to your true airspeed. So we're going to flip it around to this 10. So the thing you have to know about a flight computer is that it has what's called a floating decimal. That just means that this can represent 10, it can represent 100, it can represent 1,000, and your calculations are still going to work out correctly. So once we have the TAS arrow lined up with 10, in this case 100 knots, we're going to shift to this inner ring right here, and we're going to spin it around until this little arrow that says TC, or true course, is lined up with 12 degrees, which is what we plotted. So it's about there. Alright, so once you have this, you're going to find the angle from which your winds are coming from, in this case 330, which is over here. And you need to track down this line right here to its speed. So each of these rings represents 10 knots of wind speed. So 10 knots, 20 knots, 30 knots, etc. And we said that our wind was at 25 knots. So we're going to track in. We see that's 10, that's 20, 25. There's already a little bit of a mark there if you can see that. And now we are going to look at our crosswind component. So whenever you're dealing with a magnetic heading, you want to find out how much of the wind is blowing you either to the left or to the right, because that's going to affect the way your plane moves through the air. So there's a mark right there, that's about 25. We're going to track down to this horizontal axis and see that that corresponds to about 17 on this axis. So now that you have 17, you need to convert that into the crab angle. The crab angle is just that component of wind that you need to factor in for. So we said that it was about 17 on this scale right here. So you go back out to this outer white ring, you see where the 17 is, and then you look on the inner blue ring with what degree 17 most closely aligns to. In this case, it's 10 degrees. So our crab angle is going to be 10 degrees. So crab equals 10 degrees. Now, because it was on the left-hand side, it was a left crosswind, you can kind of see there's a little subtraction sign right there. We're going to subtract our crab angle from our true course. So 12 minus 10 is 2. So now we have 2 degrees. But we still need to factor in our magnetic variation, which we said was 10 degrees east. So again, you subtract easterlies, you add westerlies, so we're going to subtract another 10 from 2 degrees, and obviously you can't have negative degrees, so it works out to 352 degrees. All right, so now we go back to our possible answers, and we see that they have 12 degrees listed, which was our true course. They have 2 degrees listed, which was our magnetic course if you had just factored in magnetic variation, but they also gave us wind speeds, so our magnetic heading is 352.
I am free, yeah, yeah, come water me. Oh, oh, love you so, but if you don't.